Hi, Algebra 2 friends. Here we are in Chapter 12. We're looking at adding probabilities. The first thing we're talking about today is the idea of a simple event. A simple event is kind of just what it sounds like. It is just one event. It's like if you roll a die and you were to get a particular outcome, that would be one simple event. So for instance, rolling a 1 on a die is a simple event. So we can also talk about compound events. Compound events are events where one outcome will not be the only possible outcome. So for instance, rolling a die and getting an odd number. Rolling a die and getting an odd number would be considered a compound event because there's a number of ways that that can occur. So when we think of a compound event, it's an event that consists of more than one simple event. That brings us to this idea of mutually exclusive events. Let's consider a deck of cards. You have a deck of cards, and I want to know like the probability of picking a 5 or picking a 10. Those two events are mutually exclusive because if I pick a 5, that is not going to affect me choosing a 10. So I would write this as the probability of 5 or 10. And notice this is or. So it's not like the probability of choosing a 5 and a 10. It's the probability of choosing a 5 or a 10. It would be the probability of choosing 5 plus the probability of choosing 10. I'm creating a larger pool of options for me because I'm like 5 or 10, right? And so those two things are mutually exclusive because I can't, when I pull a 5, I'm definitely not pulling a 10. So what, I know that sounds really weird. It'll make better sense when I talk about what inclusive events are. Inclusive events are events that shape one another or that have an effect on one another. So let's consider our deck of cards again, and let's think about what is the probability of me pulling a 4 or pulling a card with a heart on it. Clearly, I could consider, the probability of pulling a 4 and then the probability of pulling a heart, right? A heart card. Can anybody figure out where the problem is or where the overlap or the inclusiveness of this happens? It happens because somewhere there is a 4 of hearts in the pack. So there is that we need to be concerned about. So we've, in a sense, double counted that event. So we need to subtract out the probability of 4 and heart. And that's what we do with inclusive because there's an overlap. So inclusive events have kind of an overlap, whereas mutually exclusive events do not. Before we get to this example, let's take a look at what we ought to know. We need to realize that when we're dealing with probability of mutually exclusive events, we have situations where the two events, the probability of one or the other, will just be the same as the sum of the probability of each independent event. So with that, let's consider Keisha. Keisha has a stack of 8 baseball cards, 5 basketball cards, and 6 soccer cards. If she selects a card at random from the stack, what is the probability that it is a baseball or soccer card? Well, they can't be the same thing. There's no overlap in being a baseball or a soccer card. You're either one or the other. And so with that in mind, to find this probability, that is the probability of baseball or soccer card being chosen, we would need to calculate the probability of a baseball card plus the probability of a soccer card being chosen. And so we can see that the probability of a baseball card would be 8 out of, I'm getting confused with basketball, would be an 8 out of the entire number, which is 19, plus the probability of a soccer card being pulled would be 6 out of 19. So we're going to add up those probabilities, and we see that there's a 14 out of 19 chance for that to occur. And it makes sense, right? It makes sense that, anytime we are considering probability, the desired outcome, there's 14 different possible desired outcomes out of the total number of outcomes would be 14 over 19. Example 2, 3 mutually exclusive events. There are 7 girls and 6 boys on the junior class homecoming committee. A subcommittee of 4 people is chosen at random to decide the theme for the class float. What is the probability that the subcommittee will have at least 2 girls. So we're trying to consider what is the probability of having girls on the subcommittee that number 2 or more. And so basically we need to figure out the probability of having 2 girls on the subcommittee, and also the probability of there being 3 girls chosen for the subcommittee, and the probability of there being 4 girls chosen for the subcommittee. So that's how we would calculate that. And so to figure out the probability of 2 girls on the subcommittee, you realize that we're going to use combinations. And so the full possible, the total possible number of things that can happen would definitely be 13, since there's 13 students altogether. 13 choose 4. And so that's going to be a denominator for each of these. Let me write that down. So this being the denominator for all of these probabilities, now we need to consider what the numerators are. And so if I choose 2 girls, that's going to be 7 girls choose 2, but then that means I also need to choose some boys, and out of the boys, I'm going to choose 2. So 6 boys choose 2. If I choose 3 girls, that means 7 girls choose 3. And you know what that means? I've got to choose 1 boy. And so 6 choose 1. And finally, 4 girls, it would be 7 girls choose 4. And so once I calculate these values, I'm going to be able to come up with my probability. So what we get when we do these calculations, for this first one, we would get 315 out of 715, and then 210 out of 715, and 35 out of 715. And then finally, when we add all of that up and we reduce it, we get 112 out of 143. And of course, we can have our decimal answer, which is 0.78, a probability of 0.78. So you remember us talking about inclusive events that kind of overlap, and this would be the formula that we're going to think about. In order to calculate the probability of A or B, we'd have to consider the probability of each individually, but then we have to subtract out the overlap. And so we'll see that in this next example. The enrollment at Southburg High School is 1,400. Suppose 550 students take French, 700 take algebra, and 400 take both French and algebra. What is the probability that a student selected at random takes French or algebra? So we're calculating the probability of taking French or algebra, and you know we're going to have to find the value of the probability of students taking French, and we're going to add to that the probability of students taking algebra as well. But in this case, we've actually double counted, right? There are some students who are taking both French and algebra. So it's like if I'm checking my rows and I count all the French students, and I'm checking my rows and I count all the algebra students, there's definitely names that are on both lists. So I need to subtract out a certain amount. And that certain amount is the students who are taking both, so I can avoid that double counting. So let's get started with these calculations. We know that there are 1,400 students, so our denominator is going to be 1,400 for each situation. And then the next thing we need to calculate is the numerator. How many students are taking French? So we have 550, algebra 700, but the overlap, who are taking both because we've counted those kids twice, is 400. So we're going to reduce these fractions and calculate the value. I reduced this incorrectly. This should have been 14. So now we can go ahead and calculate this. We're going to add 11 and 14, and then we're going to subtract 8. And it looks like, let's see, we get 17/28 as the probability of a student who's taking either French or algebra. And believe it or not, we've reached the end of the video. That's all we have for today. What we should probably do is talk if you have any questions about any of this stuff. Definitely try your best to do the examples in the assignment, and I look forward to talking to you all soon. Take care. Bye-bye.